So now we begin lecture 66 on particle swarm optimization. This is part 1 of the lecture, and I am Dr. Ranjan Ganguly. Now this is the third of the methods we have covered as far as stochastic optimization is concerned. We started with genetic algorithm, GA, then we started with SA, and now we are into particle swarm optimization, also known as PSO. Now, PSO is a relatively new heuristic method for optimization. It was introduced by Kennedy and Eberhardt in 1995. It's a derivative-free method, just like the methods we discussed before for stochastic optimization. You don't need any gradient calculation. And the heuristics in this method come from a field which we can call sociobiology. Now, PSO comes from the fact that whenever we look out into the world, we see various creatures which tend to flock together. For example, we see birds flocking when they are flying through long distances. We see schools of fishes when they are foraging for food, and we also see swarms. So all these situations happen because there is something better to be gained by flocking together and having social behavior rather than having a purely Darwinian behavior of pursuing your own self goals. So this fact led Kennedy and his co-workers to look at this particular worldview and codify it into PSO. Now, if we look at the behavior of bird flocks, here we will see that when they are flying, they do something like formation flight, and all the members of this bird flock maintain their positions and velocities while they are essentially performing two tasks. They are moving towards some food or they are fleeing predators. This is some of the basic tasks which are performed in nature because of the problems creatures face. And so we are going to look at why and how these particular flocking behaviors take place and what is the good point for such behavior. Now, whenever we have a school of fish, for example, what happens is that each fish essentially benefits from the discoveries which the different group members make while searching for food. For example, what happens is that you can picturize the sea in a manner where food is located in a patchy manner throughout this sea. Now, when fish stay in a school, they have access to the knowledge of the whole school regarding the food sources. And this access to the complete group knowledge can actually be superior to the problems you have because of the competition for food within your own group. So actually here a deliberate choice is made by these particular creatures to stay in these large groups because the good point about staying in a group outweighs the problems caused by competition within the group itself. Now we expand this concept to, for example, humans, primates, and so on. We will see that social behavior is important, and social behavior and learning lets a person to solve problems and advance in society. So we will distill this into two main concepts about how swarms or groups behave. Whenever an individual is present, this person or creature knows their personal best performance till date. They also have a good concept about the global best performance of the group. So for example, to consider a case of students in a class, each person would know his or her marks or grades in the class till date, till today. And also this person would typically have a good concept or estimate of the best performance in this entire class. So it's very typical that the students of the class would know the marks or grades obtained by the department topper. And this case also takes place if you look at any examinations, any group or member in a team. They would typically know who is the best member in the team and what has been their own personal best performance. So whenever the creatures are interacting with the different individuals in the society, all the informations about the personal best and the global best is typically known to all these people. So essentially what individuals do is that they use this knowledge of their personal best and the global best to make various decisions and to move forward in society and find better solutions. So essentially people are always blending this particular combination of personal best and global best. So this is the main thing to learn from sociobiology as far as particle swarm optimization is concerned, at that we have two key concepts which we need to keep in mind. One is to keep track of the personal best, and the second is to keep track of the global best. And while keeping track of these two things, we can blend these two particular things to essentially decide which direction to move in the future. So there is a lot of philosophy behind this which one can even use in one's own life, and again here it is being used in optimization in the context of maximizing or minimizing functions. So if we look at the complex social behavior which takes place, the objective of the social behavior is always to optimize the performance of the species concerned. And this mathematical behavior of social behavior can provide rules for numerical optimization. So PSO draws its inspiration from social optimization. One of the advantages of PSO is that it uses very simple mathematics. You will not see any exponentials here like you saw in the essay. You will not see any binary real encoding decoding kind of problems which we saw in GA. It's actually very simple numbers which you add and multiply. So all you do in this particular method is add and multiply. So it's very easy to code this method even if you do not have much knowledge of mathematical optimization. And in fact, you do not need a lot of knowledge of mathematical optimization or even of mathematics to do PSO. And that is why PSO is a very widely used method. And many similar methods have come out which are based on swarms. PSO works well with nonlinear functions, multimodal problems where there are several local minima. It essentially flies through the design space into the unknown regions of the design space. So you can contemplate PSO as a kind of swarm which is moving through the design space in search of the best possible solution. Each design variable X here is modeled as a coordinate of a particle in the design space. So essentially that's where the word particle comes from. You can consider a particular particle in the design space, and for this particle there is this value X which is the coordinate for the design variable. Now, besides this value for position, reflecting the location of the design variable, each particle also has a velocity with it. So this is an interesting aspect of PSO, and you can relate it to social life in general, is that there is a location for every creature and then also a velocity of this creature with which this creature is moving around in the design space. Now all the particles of the swarm will always have a non-zero velocity. This is one of the aspects of PSO, and therefore the swarm never stops flying in the design space. So that's something which helps the PSO method. Now for each particle location or coordinate x, there is a value of the cost function or the objective function f of x. So again, this is just like the methods we discussed before. We are going to use a population here, and this population is going to be of these particles, and we are going to work on this particular population. And each particle remembers the local best coordinates and the global best coordinates. So this is another aspect of PSO. These two pieces of information are then going to be combined together in a particular formula, which is going to let us move around in the design space. So we are going to discuss the mathematics of the PSO in the next lecture. In this lecture, what I introduced to you is the basic concept behind PSO, how we are coming up with this particular concept of the local best and the global best. And you can look around yourself in many aspects of life, and you can see that most of our decision making comes by seeing the personal best we have done till now, and also the global best which has been done around us, and how we can combine these two aspects together to make our decisions for the greatest good. So we always try to blend these two particular things. So I'll see you in my next video.